Salam sejahtera and good afternoon. My name is Alvira Q and I am a student at University Tun Husin on Pagoh campus. I am here today to present my final year project proposal 1 on the evaluation on the phenolic constituent of the Phytolus neroli extract as affected by the high pressure processing (HPP). I will be supervised by the Associate Professor Matya, Dr. Nur Ahmazila binti Muhammad Fauzi throughout this project. In this proposal presentation, I will provide more details on the background, significance, and the methodology of this project and also the expected outcome. Thank you for listening and I hope you find this proposal interesting and informative. So these are the list of the content I will be discussed in this presentation. In the background of the study during my research, I found that Pinolia neroli, particularly known as a dukung anak, can cure a variety of illnesses such as loss of appetite, gout, constipation, scabies, thyroid fever, asthma, and also many. Many biological activity like antibacterial exhibited the chronic respiratory diseases (CRD) caused by the Mycoplasma galaxitium can be treated by the Pinolia extract. It was reported that up to 65% of growth in the Mycoplasma galaxitium is inhibited when 30% of the Pinolia extract is used. Another findings are the existence of the quercetin has a greater tool potential as a natural antioxidant compared to vitamin E. So besides, metallic extract from the Pinolia leaf support the defense from ulcerations and minimize the inflammation as shown by the mucosal layer regenerations and the significantly reduce the hemorrhage and edema. So this show the benefit of the bioactive compound that can be found in the P. neroli. So extraction is a crucial step to extract the biological activity from the herb plants. Therefore, the high pressure processing is recommended as it's used as a tribalizing cool extraction technology. So during the extraction, the plant cells wall and the membranes are damaged by pressurized up to the 900 MPa, which causes an increase in the solid mass transfer rate. Hence, more bioactive compounds can be potentially extracted within the short time. So HPP is a promising alternative extract technique for rapidly extracting phenolic compounds from the water crease with a reducing time. So this study conducted to evaluate the phenolic constituent of the Pinolia as if it is affected by the high pressure processing. So this study also involved profiling the phenolic compound via HPLC with a selected standard screening through FTIR and also determinations of total phenolic content (TPC) and also total phenolic content (TFC). Most of people use the traditional medicine to cure a variety of illness in the past due it's more affordable compared to the modern medicine. So locals are concerned about the benefit offered by the local herbs, Phytolus neroli, in terms of their phenolic constituents, pharmacological and phytochemical properties. Thus, extraction of bioactive compound is necessary as this compound illustrate a variety of characteristics that bring a benefits to the health such as antioxidants, inflammations, and many others. So conventional methods of the extraction has a lot of disadvantages such as time and solvent consuming, energy deficient for extraction and environmental. To address the concern of using the conventional method for the extraction, high pressure processing (HPP) is recommended because it can be applied as a non-thermal extraction method for the Pinolia extract so that the bioreactive compounds such as flavonoids and phenolic compounds does not easily degraded when exposed to heat. However, there is still a lack of knowledge and research on the applications of HPP extraction on the herb plants, especially in facilitating the potential bioactive compound in the Pinolia natural form. The purpose of this study is to address by evaluating the phenolic constituents of the Pinolia as affected by the high pressure processing and investigate its effectiveness on the phenolic constituents present which has the potential in developing a new pharmaceuticals and food industry. The objective of this study are to investigate the phenolic constituents of the Pinolia which is affected by the high pressure processing (HPP). Second is categorize the phenolic compounds of the Pinolia neroli through a HPLC with a selected set standard. Third is determine the total phenolic content (TPC) and the total phenolic content (TFC) of HPP extracted P. neroli and compare with a conventional method. Scope of study. First, fresh sample of pea niruri will be collected from Cha'an Johor, Malaysia. The dry leaf will be grounded into the powder mixed with the distilled water with the ratio 1 to 20. Second, extraction method used for the pea niruri is using the high pressure processing HPP, which is located in the UPM Serdang, Johor, Selangor. The HPP pressure will be conducted at the different pressure 200 MPa and also 600 MPa, and different treatment time 5 minutes, 10 minutes, and 15 minutes. So phenolic compounds of phenolic extract were determined by the HPLC with the selected standard and screening through a FTIR. 4. The total phenolic content TPC and the total phenolic content will be evaluated and by using the phenolic Chow method and standard method respectively. 5. The result obtained will be further analyzed using the Microsoft Excel software. Optimization data will be obtained by the Response Surface Methodology (RSM). Significance of this study: the application of HPP as a cool extraction method for the plant herbs might be a new and promising solution for the process of extracting bioactive compounds. This can be proven by a successful of HPP as the most effective solution in the preserving in the various applications for the product in the food worldwide. So as the result, HPP might be the most appropriate technique for the extraction pea niruri plants as compared to the traditional method. So consequently, the finding from this project will be contribute to the development of pharmaceuticals and food products. So these are the overall literature review, which consists of 5 sections. So I will explain in the next slide. So now we have entering to the part 1, a background study of the Phytalus and Pteris niruri. So Phytalus species found in the tropical and subtropical regions such as Africa, South America, Asia as well as Oceania. So one of the uses in the Pteris species in the drug formulation were the bioactive compounds in immunomodulatory activity, which draw the natural product expert with a keen interest in their effectiveness, low risk of the cytotoxic on the normal cells, and the few side effects. Other studies found that the Pteris extract from the P. platurus, P. urinaria, P. watsoni, P. polypilus, and P. empirica have shown a significant suppress various cancer cells line while preserving a normal cell. So this extract reduces the proliferations of the cancer cell by preventing DNA fragmentations and mitochondrial multifunction. So in the figure 2.2 show the major bioreactive compound that can be found in the Phytalus species, which is piletin and hypropylentin. Now I will introduce you about the Pteris niruri plant herb that will be used for this study. So P. niruri is a tropical plant that classified as the part of piletin cat family that frequently employed in the traditional medicine, known as a rich source of the antioxidant. A study found that by increasing the levels of the reduced glutaminic GSH, catalyte, CAT, and superoxide dismutase in the kidney, brain tissue, heart, and red liver, is possible to lower the level of the T-bar in the cetrozone-toxic induced diabetic rat. In the rat study, ethanolic extract from the pea niruri eventually inhibited the growth of ulcer when combined to indomethacin and anti-ulcer effect of the alkaloid for methoxysaccharinide, gallic acid, beta-cetotetracycline, and lactic acid have been related. So figure 2.3 is the morphology of the pea niruri. Next, I will explain briefly about the high pressure processing HPP as a main process of the pea niruri extract. HPP is commonly used to process a food undergoes the high pressure to 900 MPa, so it can be used independently in the food industry or in the conjunction with other conventional technique. So the uses of HPP has been successfully proven that lycopene can be extracted from the tomato paste, extraction from the folic or from green tea leaf with higher extraction yields compared to conventional methods of the heat reflux method. So reducing the amount of isocyanatocolumn while raising the amount of enantiohormone in the beer wood with the physiochemical properties. So this technology was discovered to raise the effectiveness of the process, reduce the extraction time, offer the uniform pressure distribution, low temperature extraction and have the ability to extract the bioactive compounds from the plant's material. So figure 2.4 is a schematic diagram of HPP, which comprises a yoke machine, material handling system, and also proportional integral derivative. Now we have entering to the part 3 definition of the TPC and also TFC. Total phenolic content TPC is a method to identify the quality of the phenolic compound in the sample, which is by using the phenolic Charcot technique. So amount of the total phenolic measure in the mg per gram. So it's only provide a measure of the total phenolic content, but it doesn't provide information regarding to the specific phenolic constituents presents and the health benefit of the sample. Total phenolic content TVFC assess the qualitative phytochemical screening and its beneficial properties. So one of the findings can be discovered that heating extraction process may be lower the flavonoid content than the macerations. So higher temperature may be affect the phenolate compound in the pinery. So these are the equipment used to determine the TPC and TFC, which is ultraviolet visible UV with spectrophotometry photometry. So it is used to measure the light absorbance across the ultraviolet with the range of 180 to 360 or the visible range 360 to 780 radiations by the chemical species in the solution. Next, we have a screening through a FTIR, which to identify the functional group and the structural that exists in the compound. So with the help of statistical program, a single samples can be include a wide diversity of the information that usually with the high complexity. So the simple method for the liquid samples is insert one drop of the samples between the two sodium chloride plates. The drop of the sample will be cast the thin film to form between the plate. So we have HPLC to separate, identify, and qualify the active compound that exists in the analysis and biochemistry. So they have two components that exist in the HPLC, which is stationary phase and also mobile phase. So it's require a polar organic solvent like a methanol or acetic nitric and nucleic acid like phosphoric acid or acetic acid to extract and isolate the phenolic compounds from the herb plants. So in the figure 2.11, it shows the equipment that we have in the material laboratory utilization Pagoh. Design of experiment, we have a responsive surface pathology RSM used for the optimization process to evaluate the numerous variables associated with the evaluations of the consumer in the short time. So it can be divided into two. First is CCD with center composite design, which is a single variable or the culinary effect of the variables to respond can be identified. A second is the box Behanken design BBD, have a three-level, three-factor design that use a set of experimental point arranged in a cube or hypercube. So these are the overview methodology that proposed in this study. So it starts with the sample preparation and the collections of pinery from Jaan, Johor, Malaysia. The plant sample will be washed with the clean water after that, using the oven to dry the plant sample for 48 hours at 50 degrees Celsius. This dry plant sample will be grind into the powder form by using the grinding machine. 150 ml polyethylene tetride bottles are filled with the 1:20 ratio solution of powder plant in the distillated water. Next, we have two processing that involve, which is HPP and also conventional method. HPP will be conducted at the two different pressure, 200 and 600 MPa, corresponding to the three different processing time, 5 minutes, 10 minutes, and 50 minutes. So the HPP pinery extract will be tested for the three tests: total phenolic content TPC and total phenolic content TFC using the phenolic Charcot method and standard method. Second is screening of the phenolic compounds using the FTIR. Third is the determinations of phenolic compounds using HPLC. After that, we will obtain the data analysis through the RSM by using the Design Expert 13. HPP that involve HPP unit Everett Technology Agro USA will be carried out at the University Putra Malaysia in Serdang, Selangor, Malaysia due to unavailability equipment in UTH and Pagoh. The bottles that contain piniruri and also the distilled water will be placed into the HPP vessel and will be processed under the different pressure 200 and 600 MPa at the different processing time, which is 5 minutes, 10 minutes, and 15 minutes. So what manual number 4 filter paper is used for the filter the mixture after the HPP process. The filter is collected and stored at the negative 20 degrees Celsius in the room temperature until the analysis. So for the conventional method by boiling, 5 gram of powder P-dilinuri will be mixed with the 100 ml of the distilled water in the beaker. So a magnetic stirrer is used to ensure the mixture is continuous and uniformly mixed during the extraction process. So the sample is then centrifugal for the 10 minutes at the speed of 10,000 RPM at 26 degrees Celsius. So overall extraction yields can be obtained through the formula that I have present in the slide. For the testing, we have HPLC, also FTR. First, HPLC is to qualify and identify the phenolic contents and phenolic content, where the 1 gram of the phenolic will be weighed with the electronic weighing machine into the centrifugal tube over the 20, which is 25 milliliter, where the methanol hydroxide, which content of 100% will be added. The mixture will be placed in the HPLC for the analysis based on the phenolic compound standards. So analysis of phenolic compounds will be performed on the HPLC, which is the mobile base composed of 1 aqueous acetic acid solution and 100% of methanol hydroxide. So the injection volume will be using 5 liters and the flow rate is 0.8 milliliter per minute at 25 degrees Celsius. For the FTIR analysis, it can determine the existence of the bioactive compound in the plant extract sample. So for the mid-infrared, it can measure the range between 400 to 4,000 for the 1 data point per 1 cm 1 resolution. So a single drop of HPP extract is applied to the crystal surface to conduct the analysis, and the spectra are reported in terms of percentage transmitted. For testing, to determine the total phenolic content, we can use a phenolic Chio region, and then the absorbance of the solution will be determined using the UVV spectrometric at the 760 N absorbance. So the TPC plant extract samples are measured in milligram of gallic acid equilibrium per 100 gram of samples. For the limitations of the flow, for determination of the total phenolic content (TFC), we can use aluminum chloride technique, where the absorbance of the solution will be determined by the UVV spectrometric at 510 absorbance. Quercetin will be used as a standard. So for the data analysis, the ideal binary extraction condition will be determined by using the RSM design expertine with the 3-level fractional central composite design CCD. The HPP of the plant will be conducted in the different pressure 200 and 600 MPa, and also different processing time 5 minutes, 10 minutes, and 15 minutes. So these are the tables that I have run in the design expertine. So it gives us this raw data. So to conclude that the whole study is based on the finding and expectation result. So high pressure processing can serve as a promising and safety technique for the extracting bioactive compound from the natural material piniruri. So this research is expected to provide useful data and information on the phenolic constituent of the HPP extracted piniruri. So these are the Gantt chart for PSM1 that I have made throughout 15 weeks for this project. I think that's all from me. Thank you.